Welcome to Tech Tomorrow. Today, we're venturing into the captivating realm of space habitats and the revolutionary technologies that are turning the dream of living beyond Earth into reality. As humanity looks to expand its horizons beyond our home planet, the development of space habitats is becoming increasingly vital. These habitats are not only crucial for long-duration space missions, but also for potential colonization of other celestial bodies. With the growing interest from space agencies like NASA, ESA, and private companies like SpaceX and Blue Origin, the future of space habitats is not just a fantasy, but a burgeoning reality. Let's explore how these pioneers are shaping the future of living beyond Earth. Part 1. Lunar Habitats. The Artemis program by NASA aims to establish a sustainable human presence on the Moon by the end of this decade. This ambitious program includes a series of missions designed to explore and utilize the lunar surface. Key to this initiative is the development of technologies such as inflatable modules and 3D printed structures using lunar regolith, the Moon's soil. Inflatable modules, developed by companies like Bigelow Aerospace, provide a lightweight, compact solution that can be expanded once on the lunar surface, offering spacious living quarters for astronauts. Additionally, 3D printing using lunar regolith, a concept pioneered by companies like Icon, allows for the construction of durable and sustainable habitats using local materials, significantly reducing the need to transport building materials from Earth. These innovations are crucial for creating habitable structures that can withstand the Moon's harsh environment, including extreme temperature fluctuations and micrometeorite impacts. Part 2. Mars colonies. Colonizing Mars presents unique challenges, from its thin atmosphere to its extreme temperatures and high radiation levels. SpaceX, under the leadership of Elon Musk, envisions a future where humans can establish a self-sustaining colony on Mars. The Starship spacecraft, designed by SpaceX, is pivotal in this vision. Capable of transporting large numbers of humans and cargo to the Red Planet, the Starship is set to revolutionize interplanetary travel. Building Martian habitats will require advanced materials that can protect inhabitants from the harsh environment. Innovations such as radiation-resistant building materials, developed by NASA and other research institutions, and autonomous construction robots, like those being developed by NASA's Swarmy robots, will play a crucial role. These robots can work in tandem to build habitats and infrastructure, reducing the need for human labor in hazardous conditions. The integration of closed-loop life support systems, which recycle air, water, and waste, will be essential for maintaining a sustainable living environment on Mars. Part 3. Space stations and orbital habitats. The future of space stations looks promising with the continuous development of the International Space Station, ISS, and the advent of new commercial space stations. The ISS has been a cornerstone of international cooperation in space exploration, providing a platform for scientific research and technological development. Companies like Axiom Space are working on commercial modules that can be attached to the ISS and eventually operate as independent space stations. These modules will support a variety of activities, including research, manufacturing, and even space tourism. Furthermore, the concept of orbital habitats, such as rotating space stations, is gaining traction. These habitats, envisioned by companies like Orbital Assembly Corporation, aim to create artificial gravity through rotation, providing a more Earth-like environment for long-duration missions. Artificial gravity can help mitigate the adverse health effects of long-term exposure to microgravity, such as muscle atrophy and bone loss. Part 4. Life support systems. Maintaining a habitable environment in space is vital, and life support systems play a crucial role in this endeavor. These systems ensure a continuous supply of clean air and water, essential for the survival of astronauts. Advances in air and water recycling technologies are being developed to create closed-loop systems that minimize the need for resupply missions from Earth. For example, the Environmental Control and Life Support System, ECLSS, on the ISS recycles air and water, significantly reducing the amount of consumables that need to be transported from Earth. Innovations in food production, such as hydroponics and aquaponics, allow for fresh food to be grown in space. NASA's Veggie experiment, which grows plants in microgravity, is a step towards achieving this goal. Efficient waste management systems are also essential for ensuring a clean and sustainable habitat. Technologies that convert waste products into usable resources, such as water and nutrients, are being developed to support long-duration missions. Part 5. Radiation protection. Space radiation poses a significant risk to astronauts, especially for missions beyond the protection of Earth's magnetic field. The harmful effects of radiation include increased cancer risk, damage to the nervous system, and acute radiation sickness. Innovative solutions are being developed to protect astronauts from these hazards. Radiation shielding materials, such as polyethylene and hydrogen-rich compounds, are used to create protective barriers around living quarters. NASA is also exploring the use of magnetic fields to deflect harmful radiation, similar to how Earth's magnetosphere protects us. Additionally, water and fuel tanks can be strategically placed around habitats to provide additional shielding. Understanding the radiation environment and developing effective protection strategies are essential for the safety and health of astronauts on long-duration missions. Part 6. Psychological and social aspects. Living in space for extended periods can have profound psychological and social impacts on astronauts. The isolation, confinement, and distance from Earth can lead to mental health challenges, including anxiety, depression, and interpersonal conflicts. Addressing these issues is crucial for the success of long-duration missions. Virtual reality, VR, and augmented reality, AR, technologies are being utilized to provide mental health support and entertainment. These technologies can simulate familiar environments and social interactions, offering a sense of connection and normalcy. For example, VR can be used to create virtual family gatherings or immersive nature experiences, helping astronauts cope with the psychological stresses of space travel. Additionally, structured schedules, regular communication with loved ones, and access to psychological support are essential for maintaining mental well-being in space. Part 7. Top companies leading the way in AI-driven manufacturing. 1. NASA, leading the Artemis program and developing technologies for sustainable lunar habitats, such as inflatable modules and 3D-printed structures using lunar regolith. NASA is also pioneering life support systems, including advanced air and water recycling technologies that ensure a continuous supply of clean air and water. These systems are crucial for maintaining a habitable environment in space. Additionally, NASA is developing innovative radiation protection solutions, such as radiation shielding materials and magnetic fields, to protect astronauts from harmful space radiation. 2. SpaceX. SpaceX, under the leadership of Elon Musk, is at the forefront of Mars colonization. The company's Starship spacecraft is designed to transport humans and cargo to Mars, revolutionizing interplanetary travel. SpaceX is also developing advanced materials and autonomous construction robots for building Martian habitats and infrastructure. These robots can work in tandem to build habitats and infrastructure, reducing the need for human labor in hazardous conditions. The integration of closed-loop life support systems, which recycle air, water, and waste, will be essential for maintaining a sustainable living environment on Mars. SpaceX is also exploring innovative radiation protection solutions, such as radiation shielding materials and magnetic fields, to protect astronauts from harmful space radiation. 3. Axiom Space. developing commercial modules for the ISS and independent space stations, supporting research, manufacturing, and space tourism. Axiom Space is also innovating in the field of orbital habitats, including rotating space stations that create artificial gravity. These habitats provide a more Earth-like environment for long-duration missions, mitigating the adverse health effects of long-term exposure to microgravity. Axiom Space is also developing advanced life support systems, including air and water recycling technologies that ensure a continuous supply of clean air and water. Additionally, Axiom Space is exploring innovative radiation protection solutions, such as radiation shielding materials and magnetic fields, to protect astronauts from harmful space radiation. As we've explored today, the future of space habitats is filled with exciting possibilities and innovative solutions. From the Moon to Mars and beyond, these advancements are crucial for the future of space exploration and potential colonization. The development of sustainable living environments in space not only supports human missions, but also paves the way for a new era of space travel. As we look to the stars, the pioneering efforts of NASA, SpaceX, Axiom Space, and other organizations are making the dream of living beyond Earth a reality. We invite you to share your thoughts and ideas in the comments section below. Thank you for joining us on this journey into the future of space habitats. Don't forget to like this video, check out our community, share with someone you know, smash that subscribe button, and hit the bell icon to stay updated with all things tech. Until next time, stay curious and keep exploring the future of technology with Tech Tomorrow.